Here are some pictures of a mercury barometer at a variety of different pressures. Remember that the way a barometer works is that the atmospheric pressure pushes on the surface of the mercury in the open dish, and the higher the atmospheric pressure, the greater amount of force the atmosphere can push on that mercury in the dish, and the higher it rises inside the little column. 1 atmosphere of pressure is defined as being the amount of pressure it takes to push this mercury up to 760 millimeters off the surface of the dish. So our first barometer right here, when the atmospheric pressure is 1 atmosphere, has a mercury column height of 760 millimeters. If the atmospheric pressure drops to 0.75 atmospheres, it's only 75% as much pressure, and that means that the column of mercury will fall to a lower height. Specifically, it'll be 75% the height that it was when the pressure was 1 atmosphere, or 570 millimeters of mercury. If the atmospheric pressure rises to 1.25 atmospheres, that means that the mercury will be pushed by the atmosphere higher into the tube, and it will be more than 760 millimeters of mercury. Specifically, it'll rise to 950 millimeters of mercury. Our last one is a little counterintuitive. If I make the diameter of the barometer twice as wide, a lot of people's inclinations are to think that the mercury level should only be half as high. But since pressure is force per area, you increase the surface area of the mercury in there, but since it's force per area, you get more force to go with that increase in area. And so the height of the mercury column is still 760 millimeters tall. You'll notice when they talked about barometers, they didn't discuss at all what the diameter of that tube had to be in order for 1 atmosphere of pressure to push the mercury column up to 760 millimeters of mercury. Number 2 is a conversion problem, just involving some dimensional analysis. We have to take kilopascals, or take millimeters of mercury that they use at the doctor's office on their blood pressure cuffs and convert that into kilopascals and atmospheres. So here are some conversion factors from some notes that you've taken. These factors will also be given on a resource sheet that I will give you when I get back to school. And we're just going to convert millimeters of mercury to kilopascals and millimeters of mercury to atmospheres. So this first 2 sets of conversions gets us from millimeters of mercury to kilopascals. So if you did blood pressure in kilopascals, your normal blood pressure would be 16/11. And here we are going millimeters of mercury to atmospheres. So if you did blood pressure in atmospheres, normal blood pressure would be 0.158 over 0.11. Lastly, you needed to make some drawings with this as your reference point. So with this picture being your reference point, if I put more gas particles in the container, you will see that it's now more crowded. I have 3 particles hitting the wall instead of just 2 particles hitting the wall. That's going to cause the pressure to increase above 0.95 atmospheres. If I cool the container down, the particles are going more slowly. So I represented that by taking off one of the speed marks, and we only have 1 particle hitting the wall. The second particle hasn't quite gotten there yet. The fewer arrows bouncing off the wall represents less than 0.95 atmospheres of pressure. And lastly, if I cut my container size in half, but keep all 6 of those particles in there going at the same speed, cutting the particles in half, or cutting the container size in half, will cause the particles to hit the wall twice as often, giving you a pressure that's greater than 0.95 atmospheres.